Okay, one more round of multiplication and division of radicals right here to finish up our examples. And let's take on an example like this first one right here. We're taking the square root of 5a times the quantity square root of 20a minus the square root of a. Well, in this case, we're going to have to use the distributive property. And recall that the distributive property says that if we have a number multiplied in front of a sum or difference in parentheses, we multiply that quantity outside of the parentheses by both terms inside of the parentheses. So this is going to become the square root of 5a times the square root of 20a minus the square root of 5a times the square root of a. All right, so we carry out the multiplication. These look just like some of the multiplications we were doing before, and we'll note that square root of 5a times square root of 20a is the square root of 5 times 20, which is 100, times a squared, minus, and let's see, square root of 5a times square root of a comes out to be square root of 5a squared. So we look for the perfect square factors under each of these radicals. Of course, 100 is the square of 10, and a squared is the square root of a. And of the second fraction, the radical 5a squared, only a is the perfect square. We would leave 5 under the radical, and since there are no more like terms, there's nothing else that we can do to combine or simplify this expression, and so we're done. In this second example right here, we're multiplying, we've got two terms in two binomials, and of course that indicates that we're going to have to use the FOIL method in order to multiply these guys together. And the FOIL method works for radicals in the same way that it works for variables. So what we're going to do is we're going to multiply our first terms, which is to say we're going to take 3 times the square root of 2 and multiply it by 5 times the square root of 2 as our first terms. We're going to take negative 3 and negative 3 square root of 2. So we're going to be minus 3 times 3 square root of 2 as our second term. Our outer terms anyways, our inner terms is positive 1 and positive 5 square root of 2. So it's going to be plus 5 times the square root of 2. Since it's being multiplied by 1, it's just simply itself. And of course, as our last term, we would be taking negative 3 times positive 1, so that's minus 3. All right, so let's see what's going to happen right here. In the first terms, if I take 3 square root of 2 times 5 square root of 2, that's like taking 15 times the square root of 4. My outer terms, 3 times 3 square root of 2 is 9 square root of 2. And we're adding 5 square root of 2. And we're going to subtract from all of this 3. Well, there's more that we can do because square root of 4 is 2. So this is like saying 15 times 2. I'm going to move my other constant up front here since there's no more radicals here. Minus 9 square root of 2 plus 5 square root of 2. Okay, so let's see what we can add right here. 15 times 2, that's 30. And 9 square root of 2, negative 9 square root of 2, and 5 square root of 2, that's positive 5 square root of 2, can be added as like terms, giving us minus 4 times the square root of 2. So really we're left with 27, 30 minus 3, minus 4 times the square root of 2. That's our simplified expression. There's no more that we can do with that, so we're done. Okay, one more right here, and that's our division problem over here. We've got square roots going out over here, and what we should really do is before we combine anything together, recall our division rule. That says that if we have a square root over a square root, it's the same thing as just one big old square root over everything. So we've got 5, a to the 4th, b to the 7th, and c squared divided by a, b to the 3rd, c. So we're going to have to reduce what we can out of this. It looks like 5 in the numerator There's nothing that can be done with that. But a to the fourth over a is a cubed by subtraction of exponents. B to the seventh over b to the third is b to the fourth. That's right, we subtract the exponents. And c to the second over c, that's just c all over 1. So I don't need to carry out with my denominator anymore, but what do I have left over? Well, let's look for perfect square factors. 5 has no perfect square factors. It's a prime number. A cubed, however, contains a squared, so it's a squared times a. B to the fourth is a perfect square, right? It's b squared times b squared, if you really want to think of it that way. And c, well, that's by itself as a factor, so what can come out? Well, a squared and b times b, right? So that's going to be b squared when we bring it out. So we're actually going to have a times b squared multiplied by the square root of what's left over, which is 5a and c. That's going to be our simplified form. And so we're done. See you guys in class.